Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at the Markonikov reactions, but the resulting product has an anti-Markonikov orientation. It's opposite what we saw before. And we're going to illustrate the example of hydrobromic acid in the presence of peroxide and a little bit of heat to show you what this anti-Markonikov orientation is. So the rule itself is still going to be Markonikov rule. All right, we're still going to have the same principle of having the pi bonds of a double bond, an alkene, the pi electrons being electron rich, and they can bind with an electrophile in a process called electrophilic addition. That hasn't changed. We're still going to have the alkenes pi bond be the electron rich species, much like the nucleophile or base were in the preceding topics of substitution and elimination. But in this case, we're going to have an electrophile that's a little different. All right. Here, we're going to have two steps, right? The first step was to form the intermediate, and we're still going to try to get the more stable intermediate. But the intermediate is going to be a free radical. What happens is the peroxide, in presence of heat, forms a couple moles of the peroxide radical. And these free radicals initiate the chain reaction that you've seen previously when we talked about chlorination and bromination of alkanes. And the propagation steps are basically going to be done in a manner that creates the most stable intermediate as your starting product. Here's our initial alkene. I want you to take note that this is asymmetric. Here we're no substitution. Here we're mono-substituted, this methane group. So what we got going on here is we got hydrobromic acid in the presence of peroxide and heat. Again, you're going to cleave this, the homolytic cleavage. Each of these oxygens in the peroxide is going to get one of the electrons, forming a couple moles of the peroxide radical, and then that's going to interact with the HBr, and the hydrogen is going to bond here. All right, and when the hydrogen bonds, it leaves bromine with an extra electron that's unbonded, and it's in trouble. It desperately wants an electron at that point. So you get a couple moles of this, and you're going to get bromine free radical. This is very electrophilic in nature. All right, it wants to bind to electrons. These pi electrons are a suitable target. So, following the Markonikov rule, the electrophile binds to the least substituted side. If you did that correctly, you should create the more stable free radical. So, here is the reaction that we're going to look at. We're going to have the alkene with the bromine radical, and you're going to get the alkene radical that I spoke of when the bromine, the electrophile, binds to the least substituted side, the one with the most hydrogens. All right, so if we do that, that means one of the electrons is used for the bond with the bromine, then there's one left over on this carbon. So there's your alkene free radical, and then it interacts with the hydrobromic acid to give you this product. Now this product is what's called anti-Markonikov. Notice that the bromine, what would have been normally the electron-rich species, bound to the less substituted side. Okay? Keep in mind, we did create the most stable free radical. Secondary is more stable than the primary free radical we would have gotten if we were right here with a dot and bromine over there. So this one, the secondary, is more stable. This is anti-Markonikov orientation. Again, this keeps occurring until a bromine radical and the alkenes radical unite, ending the propagation steps. Okay, sometimes you can get those undesired propagation steps with a container, or bromine and a bromine or something like that. But we don't pay attention to those products. We only will sift out and get the desired product. All right. So again, this is anti-Markonikov. We started with heat, created a couple peroxide radicals, which interacted with the hydrobromic acid, leaving the bromine very electron deficient, wanting to bind, making it an electrophile, thereby following Markonikov extended rule stating that the electrophile will bind to the less substituted side, and then once it's bound, you get the more stable intermediate, which is secondary, and then the hydrogen binds. All right, and then this will keep going until there aren't any free radicals left. Termination occurs. I hope I've clarified things enough for you to try some of these problems. They get a little bit more complicated, but not too much more for this one. The hydroboration is the other anti-Markonikov you should look out for. and it's forming a cyclical intermediate, and we will discuss that in a separate video. But the rest of them are going to be Markonikovs with these alkenes reactions. So I hope I've clarified things enough for you to have enough confidence to practice. As always, practicing is what makes this stuff easier and easier, makes you able to go through an exam faster and faster. Thanks for watching. Have a great day.